Excellent. Always glad to be first. Hey, everybody. I'm Itzhaki, CEO of Fhenix. Been in the space for several years, predominantly working on technologies associated with confidentiality, trusted execution environment, and then recently on fully homomorphic encryption, FHE. Excited to be here.
Hey guys, this is Deli from Automata. I started building in crypto since 2017. Started with also like this hardware features, TEE stuff. I've been working on research for a while before joining crypto. I mean, right now we're currently working on verification layers that actually help people to verify their machines or their workload on chain. That includes recently also the AI agent workload as well. So this is really exciting kind of area for us too.
Hello, I'm Grigore Rosu. I'm the founder and CEO of Pi². And our mission is to bring universality with respect to programming languages and virtual machines. So basically all programming languages and all virtual machines to Web3. And also with respect to proofs, all kinds of proofs, both mathematical and zero-knowledge proofs. And with that, millions of devs to Web3.
Hi, Alan here from Brevis. I'm the CSO for Brevis. So at Brevis, we do everything related to ZK, zero-knowledge proofs. So we believe that the ultimate goal for scaling up all the blockchains is to do the off-chain verifiable computing, which is why we do everything related to ZK. And then our first product is ZK coprocessor that handles the project's need to do this data access. And then we also have some related work in ZKML world, as well as something we just proposed is a modern and performant ZK VM called Pickle, which is super fast and then can prove anything that is written in plain Rust. Yeah, super excited to be here.
The history about like sort of the relationship with me and all the projects. So a lot of the panelists, like basically my old friends. Okay, let me ask one more question. So the thing is like, I believe most of you probably don't really have like sort of the concept of what kind of these projects in the panel they're doing. I want like every panelist to give just probably 1 or 2 sentences about like what you are doing, like basically to explain your technology. Because roughly I know Brevis ZK, right? Grigore on this runtime verification, Deli on TE, and also Guy on this FHE. I know all this because I doing a lot of research, but can you just give 1 or 2 sentences, just quickly explain in layman words to the audience, like what's your technology and what kind of the cool stuff you're working on?
Okay, so basically we use zero knowledge to actually prove to any kind of execution of the program to the blockchain. So that on the blockchain, you don't have to do any kind of complex computations, but rather just verify some kind of very efficient proofs. So that's basically what we call as off-chain verifiable computing, and this is all under the ZK umbrella.
So computing with any programming language is mathematical proof. You can automatically generate mathematical proofs from executions of programs. Now, all you have to do is to have a ZK circuit to check the integrity of the mathematical proof, independently of any programming language. And now you got a universal verifiable computing framework without any particular ZK VM for any particular VM or ISA. That's why we are called Pi², from proof of proof, zero knowledge proof of mathematical proof. And that allows us to build a true universal settlement layer where you can settle any claim that is provably true, including any computation in any programming language.
I can explain again, basically with Grigore tech, right? So Grigore is the creator of runtime verification. So basically he can generate proof of whatever program you have. Yeah.
And now ZK proofs on top of them.
Yeah, yeah.
Okay, so we're actually building so-called coprocessors, which is a kind of like verifiable compute mechanism that can help you to extend your trust from maybe blockchain to other offline computations. Specifically, we're using hardware to achieve this kind of verification and isolations, which is pretty useful right now for a lot of the LLM use cases, given that there's really strong like compute need to really achieve like very high throughput computations.
Maybe before I talk about what we do, just to say a few words of the problem that we're trying to solve. In our opinion, I know we've been seeing what's happening in the industry for the last couple of weeks. There are a lot of trends, a lot's going on. We think that we need to build what the industry really needs to mature. In our opinion, confidentiality is a missing component. It's the way to attract institutional. It is really the way to make blockchain as a key component of the future economic. And in order to do that, we've built a solution which enables developers at this point on any EVM chain, but it can scale beyond that, to get data confidentiality in one line of code. So basically, by integrating the Fhenix solution, they can start encrypting and decrypting the assets in any dApp that they're building. And we believe this is really the future and how we mature crypto and Web3 into that space.
That's amazing. Now I hand over the mic to Nader from Eigen.
Hey everyone, sorry I'm running late today. Ran into traffic, busy day. But okay, cool. So thanks for kicking it off. The first or the next question that I want to kind of run by everyone is what are your thoughts on the current like state of the AI agent meta? My wife was like commenting from what she's seen on my Twitter feed. She's like, is this an AI conference or a blockchain conference? And I was like, well, yeah, I don't know now, actually. It's like half of the events I've been to are like AI. But AI agents became very hyped, and I felt like we kind of went down the hype curve, and now we're kind of at the trough of disillusionment, and we're now going to come up. But yeah, I'm kind of curious on your thoughts on the current state of the agent meta. Yeah, anyone can jump in.
Okay, let me maybe start. So I came from the background of AI plus science, and then I did something related to blockchain, and then now ZK. So there's actually different levels of AI for science to distinguish different capabilities of AI agents in scientists. They do have like 4 levels. Level 0 is basically some very dumb, very easy models that do very easy tasks. Level 1 is called agent assistance. So basically, these kind of agents can assist the scientists to do some very simple tasks, to do some very simple information collection, searching, or something like that. So it's very simple. And then level 2 would be an agent collaborator. So there might be some very complicated tasks or some very complicated hypotheses that you want to test in science, so that you basically collaborate with these kind of agents. It's not like you just tell it what to do and then it does it, but it's actually something like an interactive thing, so that you together work as a team to achieve this whole goal or hypothesis test. And the third level, which is the highest level, is the so-called AI scientist, where it can itself propose some kind of hypothesis that actually makes sense towards some final goal, and it will actually iterate through itself to propose something and then solve something, and then step by step it will solve the hypothesis or achieve the final goal. So reviewing these kind of 4 levels is actually applicable to any kind of fields. And then in generally speaking, I think current status for any kind of AI agent field is more like something between level 1 and level 2, where AI agent is actually working as an assistant to many people to, say, schedule some events in a calendar, do some calls, something like that. So this is something that lies on level 1. Well, for level 2 is like you just collaborate with these AI agents to achieve like more tasks. But this is still in its infancy mode. And then as for 3, I guess like this is something that might be achieved in 5 to 10 years. So that's my understanding for current status.
I think they are a great technology, but we have to verify what they do. We have to be in control of the final results. They are great to find solutions for our problems, but we should be in charge of the problems, and we should be able to verify that they found the right solution for us. As far as that happens, I think we'll be okay as a species.
Yeah, actually, I'm a user of AI. I've actually had quite a lot of observations. So we've seen the changes, like all the like models capability has changed from just writing a maybe article to generating images, now creating code bases as well. Actually, personally, I've been using quite a lot of the coding assistant agent that are really powerful. All you need to do is just tell your need. They will just spin off like a code base that like no matter it's a like UI product, no matter it's a backend services, it's fully capable of this kind of task. Also, I've saw that nowadays models are also hitting their bottlenecks. Like if you look at what the newest release from OpenAI, right, the ChatGPT 4.5, it's the number of like compute they put in to train this kind of model is a lot, yet the gain from this kind of like doubled or even 10 times of the compute is pretty low actually. So that means that pretty much if they've consumed all the data that they could use for training, maybe next step they could really they have to like kind of create new kind of paradigm to make sure they can still deliver better model. Also that as a user, I think it's kind of a shared concern with everyone that this kind of AI providers, they're able to see your input, right? They're able to see what's your interest. If in the future, the default is you send everything to AI, now the privacy is a big issue. So that's also something that I'm trying to come up with some solution with. Right now, there might be some good way. For example, you can host the model locally because there's quite a lot of like open weight models that you can use. Or when you use this kind of AI providers service, try to be careful with your personal information, because literally you could just like replace those kind of personal info with some random words to make sure that you are not leaking too much to them. So this is what we have seen so far, and also these are really challenging part that need to be solved. Maybe from Web3, from crypto, we can come up with some solutions.
And I'll just build on top of that because I think like maybe 90% or 80% of the models that we're using today are controlled by a central entity. Like clearly everything that we do, whether that's OpenAI or even DeepSeek, they're controlled, they're managed by a central entity. And I think everybody here are in the goal of, okay, what is the next evolution? How do we prevent these models to become like basically dominating? They have all the knowledge, they have all the data. As a fun example, like my team wants to consider patenting something. Can we use AI for that? You give them the secret sauce and you ask them to help you with like writing a patent. Would you do that? Probably not. So yes, I think AI, at least the models themselves, maybe putting aside the agent part of it, is happening. It's now, we use it a lot. It transforms the working business. I think everybody gets that. I think the key question is, where does AI meet blockchain? And how do we use that both for decentralization, open source, as well as verifiability? And I think that's really what we're about to talk about.
Cool. Okay, awesome. So I guess the question I have for everyone is, what does verifiable AI mean to you? Because I feel like it is kind of a nuanced topic. While we all kind of come to a similar conclusion, everyone's explanation seems to be slightly different. So yeah, I'm just curious, if someone asks you to define verifiable AI, like what does that mean to you?
Maybe I can start first. So like in my view, I think the definition for verifiable AI is not actually on the correctness, but it's on the like expectations. So you're expecting that you're getting the output from something that you have proved or something that you are expecting. For example, if you're using some kind of models from like those providers, right? You have to be sure that you're interacting with the right model. Otherwise, it will be kind of cases that they're actually giving you a less powerful model while still charging you the same. So this could be a big issue. So this is kind of the definition I'm expecting from like the for the verifiable compute. Also, another part is there might be also a little bit like correctness there. For example, you really have to make sure that like there's no malicious part of the no matter it's AI or the agent that you're interacting with. So if you use some of the like verifiable compute technology like TE, you probably can really verify that you're interacting with the code, with the agent that you trust. Of course, you need to also like know what's running inside before you can verify everything. But with all this kind of proof, you at least know that all the parts are verified. You can trust their result. As for if there will be some correctness issue, for example, nowadays models are subject to this kind of the prompt injection attacks. Those are really difficult problem. I don't think there's good solution yet, but I think it's kind of out of scope for now.
We have verifiable AI. Every time I run a query, if I see the response, I ask for the sources, and then I go read the articles that the sources came, and I'm the verifiable entity, which is really not where we want to be, right? We want to make sure that when we're executing a model, when we're doing a query to the model, the response that we get is A, the intent response that the model was supposed to, and B, that it's accurate. And this is a very complex problem to achieve because A, most of these models today are operating on public data. So they give you a response as good as the data that they've been trained on. And even that, you still don't know that they actually computed or verified what they're supposed to. And the ability to generate just better model requires better data. That's one. And the second part is really to make sure that we have the ability to attest that when we send a private query or a query to the model, that it executed it correctly. Once we achieve that, once the models no longer end, at the end saying, don't trust this information, test it by yourself, I think that's the aim goal. And there are various ways of achieving it. I think TE is one clear way, ZKML is another. We're going to probably chat about the solutions in a minute.
So, right, so there are two different ways, two different levels at which we use the word verifiable. One is to verify the execution of a program that we believe executed. The program is known, and we just want to make sure that the result that was given to us is that program executed on the right input. That's the easy part. Now, there is verifiability with respect to what we really wanted, right? So, does this agent do the right thing for my requirements? These are my requirements. This is what I claim I want it to do. Does it really do what I want it to do? Right? So this is a different level of verifiability because now we need, I try to avoid this word, but I have to bring it, formal verification, right? So we have to formally verify that the execution or the agent, whatever it did, satisfies the requirements. And I would say the following: if the agent is smart enough to find a solution for me to satisfy the requirements, it should also be smart enough to build a mathematical proof why whatever it did satisfies all the requirements. And I think this is where blockchain comes now into the picture, because we can use blockchains to verify. So the agents can go out there, do their magic, come up with the best solution for us, and the proof that that's exactly what I wanted. And now I can the blockchains can verify, and now I can commit the result, I can accept the result.
Yeah, so verifiable AI, as I understand, is a set of tools for a special purpose, right? This kind of purpose is, to summarize, is basically to attest the integrity. It's all about attesting the integrity. The integrity could be integrity on the model, so that you want to make sure that some output is actually coming out of a specific model that you want. It can be the integrity on data, so that it is actually the right input to the right model. So these are all about like attesting the integrity, either on the model side or the data side. And then for the set of the technologies or methodologies, there can be either software or hardware. Hardware we have like TE, these kind of things, to make sure that you are running on a specific some sort of hardware that can actually help you do that attestation. And then for software, it's just a zero knowledge, where you can basically prove it everywhere. Of course, there's the overhead of the computation, but it gives you a proof that it's very easy to be verified on chain.
So there's also been a lot of discussion around the intersection of DeFi and AI. There are people that call it AI-fi, DeFi with AI instead. I don't really care what people call it, but I'm curious though, what are your thoughts around how verifiable AI will power decentralized finance / AI-fi? Maybe I'll start down here at the end.
Yeah, for sure. I think the part that makes a lot of sense at this point is as we start getting into the point where we have AI agents that trust us. These AI agents are really powerful because now we can actually allow them to interact with DeFi in the way that that we hope and expect it for it to be intended. So you can think about AI agents that do automatic lending solutions. You can think of AI agents that intersect in dark pools and so on and so forth. The key challenge is to make sure that we have AI agents that we can trust, because as AI agents mature, become more and more powerful, they will get more and more autonomy, and now becomes the challenge. Once it's working with its own autonomy, you need to have the ability to make sure that it's not just an autonomous agent, but you can also trust the response time after time. And I do want to mention one thing that I think is kind of important. AI in nature is non-deterministic, right? When you work on a model, it's not deterministic. You will get a different response every time. Blockchain, on the other hand, are fully deterministic. That's uniqueness. And everything that we're talking here is about really the intersection between this non-deterministic entity and the deterministic entity of the blockchain. And that's where we're going to see the AI agents become prominent, transitioning into the DeFi space.
But will the LLMs, won't a requirement be for them to become deterministic, to come to some consensus?
I don't foresee, like LLMs, I don't think they're going to become deterministic. That's the way they operate. They operate in a non-deterministic way. I think what you want to make sure is that even though it's non-deterministic, the response that will be produced time after time would still meet the intent and the goal of what the user is trying to achieve.
So the problem is with the blockchains, actually. This thing that all the nodes have to re-execute a program, that will not last, I think, in the future. We'll have ZK proofs, we'll have different ways to verify. Execution will happen only once. Duplication is bad in general, right? So duplication in software engineering, you cut and paste code, that's bad, right? So duplication is bad. And then it doesn't matter that they are non-deterministic. They execute the program non-deterministically, it's just one execution, generate a ZK proof, and you only have to check the ZK proof, right?
Yeah, I actually agree on that point. Because although like models are not deterministic, there might be some mechanism you can make the service deterministic. For example, you can have some kind of cache mechanism to make sure the model always respond with same reply when it saw the kind of same input. I mean, same query. But still, I mean, for most of use cases, like if it's maybe the DFAI case, right? The model lives off-chain, or the agent lives off-chain. The liquidity pool or the DeFi product lives on-chain. What happens will be every time the AI agent like does something to the on behalf of the user, it will have to come up with some kind of proof as well. Maybe it's going to be a ZK proof. Maybe it's going to be a TE proof that can include all the execution. And it only needs to generate this kind of proof once. Then it can be verified on-chain, off-chain, everywhere. And it doesn't really need to be kind of repetitive or reproducible. So it's kind of a solved issue there already. But the thing with, I think the bigger issue between the off-chain agent and on-chain DeFi is there's the trust issue. Because to those protocols on-chain, you don't really know if you're really interacting with the agent that you can trust. Because when we talk about DeFi, DFAI, the better vision is maybe we can identify if the protocol is interacting with a trusted agent, so that you can give the agent more permission, right? That's actually more interesting because the protocol can't really trust human. But if you can prove that your agent is doing things that are like in a kind of defined manner, then maybe the protocol can work with the agent and to solve some of the like trust issues. For example, when it comes to the like maybe interops, if you can really build out a intent-based also like agent-based protocol, right? Maybe there's a lot of conflicts. There's also like a lot of like win-win situations for all the participants. So this kind of trust issue is something that I think that we have to solve before we can really see the like the explosion of the DFAI. Yeah.
What does it mean to trust an agent?
So,
or that it is the right agent, right? It's just a program in the end, doing something for you, right?
yeah.
Do you care if it's that program or the other program, if it does the right thing for you?
Over here, what I mean is the protocol actually can put more trust on your agent if they have a way to know that what your agent is doing. Because
So who owns the engine, the agent?
You still own agent because it operates on behalf of you, but there's some part of it can be trusted by the protocol so that it addresses some of the trusted issues, which really remove some of the fractions that causes like a lot of like overhead in the DeFi protocol.
Yeah, to agree with that. So basically, it's about verifiable AI is about like reducing the original computation, which is like the scenario, which is 100 people, like each of them running just 10 hours of execution, and then try to reach a consensus and dealing with the determinism, versus it is reduced to the scenario where only one person just runs for like 20 hours or 30 hours, and then for the rest of them, they just take 10 seconds to do the verification instead of do the execution again, and do not have to deal with the determinism. I think this is the where verified AI can actually comes into play.
I just learned a lot, actually. That's interesting, hearing everyone's perspectives. Yeah.
Let me add one more thing. This is a well-understood concept in formal verification. There are two approaches to verify non-deterministic programs. One is called all-path reachability. You prove that on all paths you get the same result. And the other one is called one-path reachability. And there are different mechanisms to do proofs in one or another, well understood, like for more than 20 years. So there is a way to get these proofs once and for all. And then you can ZK them and done.
The next question is, what are some companies or technologies, either in AI or at the intersection of crypto and AI, that are most exciting and interesting to you that are not your own company?
Can I start? Sure. Because I will be quick. I like Sentient, and also their interest in having their agents settle their actions, their results through proofs, through mathematical proofs and zero knowledge proofs. I don't know how far that will go, but they are directly interested in that.
Yeah, from my point of view, basically, as I understand, the AI agent is something that can actually provide you with infinite personalization. So basically, it can actually be tuned to fit your own needs, because everybody's needs is kind of different, right? Everybody's preferences or trade-offs are also different. So just take like DeFi, for example. Like there are a list of different DeFi protocols that you can take advantage of, and you can just deal with them. But they just like choose one of them that's already there. But I think it's like maybe they have this kind of trade-off. Maybe their risk is too high, although their like a return is also very high. Or maybe there's something that you want some certain yield, but with lower cost or lower some risk or something like that. So basically, there's many things to tune. And then if you just tell the AI agent, it can actually search for you for your personalized DeFi protocol. That can happen. So it's not only in DeFi, but also in every other sectors or tasks. So if there's any company that is working in this area, I'm very happy to see that is happening.
I'm quite interested in the like this kind of ZK-ML. Although I'm working like on TE, but I still think that like ZK is the future, because even inside like our protocol, we use ZK to verify, to accelerate the verification of some of the like attestations on chain. I actually would like to give credits to like all the ZK VMs and also like some of the ZK protocols that create like very low level libraries that help to accelerate the like ZK-ML concept. I think EZKL is doing something on this front. Brevis also. These are really great like directions to work on. Although I know that there's limitations on the, for example, the speed and performance, but I mean, we just need some time. Like if we have really good hardwares in the future, I think this should be really the like proper way of like solving this kind of issue. Yeah.
That, and also I think the future would be a mixed solution of both hardware and software. It's not only a hardware or software solution, so it will be a mixed solution. So with that, I think also credits to Deli's companies.
On my side, I think it's there are a lot of companies in the space. I don't think we've yet seen one that is able to provide a comprehensive solution. We're really early days. There are a lot of efforts. There are a lot of tryouts. There will be novel solutions. We may end up getting verifiability not so much by ZK, but maybe something similar to like crypto economics that you guys did, very well for the non-verifiability, but maybe through crypto economics we'll get into better verifiability. The domain that I'm mostly interested is agent-based transactions. Once we're able to reach to that point where we can start seeing agent-to-agent transactions, I think if somebody's able to solve that and bring it in a verifiable way, that would be transformational.
All right, so we have about 5 minutes left. So the last question, I'll give each of you 1 minute. What would be the most exciting agent to you to kind of see live being used and kind of like if we fast forward like a year, because right now I don't think there are that many that are really all that useful. A lot of this is more theoretical, right? So yeah, so if you could kind of like fast forward a year, do you have an idea or you've seen people talking about an idea, what would the most exciting and interesting use case be?
Actually, I hope that there's a personal assistant AI agent then can take over all my work. Can take over all the Telegram chats, take over all the documentations, even take over maybe some of the banking, some of the wallet stuff. Then I just need to like maybe hear updates every morning, right? And I will also like give instructions that the agent will just carry out for me. I think there's a possibility there because I've seen like how agent is able to like write codes right now or write articles. There's just like maybe a few other kind of glue code or glue protocols that you need to write to make sure that you can connect to all the services.
I'm 100% on the AI agent-based development part. I think we're going to have a transformational period as people with limited development skill set can start utilizing AI agents to build applications on their behalf. We are now broadening the reach. We're generating a significant, huge amount of people that can bring innovative ideas into that space. And I don't think we're that far along, actually.
Yeah, maybe I want to make an analogy to the off-chain verifiable computing because, like a complex computation could happen on-chain, but we choose not to because like complex computations, if happen off-chain, can like offload these kind of computations off-chain so that the on-chain, you just do the verification, which means like a blockchain is actually doing the important thing for all these kind of computation flow. So speaking of AI agents, I think for the human, it's actually also the same or kind of similar because you want to offload all these kind of complex things. It's not complex, but it's just a tedious things or like something that you may not be good at or something that you want to do, you don't want to do. You can offload all of these kind of things to more professional AI agents and then focus on something that you truly love and you're truly good at, so as to maximize your output. So that's something that I really want to see in a year.
All right, so besides all of this, which I all want to see, I'd like to also see, and that will not happen in 1 year for sure, agents proving mathematical theorems for us. If they are able to generate programs that do things for us, they should also be able to generate mathematical proofs why those programs do what they are supposed to do. And that, I think, will increase a lot our dependability and trustworthiness in these systems. I play Go. I love play Go, and now there is absolutely no chance to beat AI right at Go. So such a beast that can think that deeply should be able to formally verify programs for us. There shouldn't be a job for people, I think, in the future.
So does that mean, when you say that, are you basically saying that programmers will become even less in demand?
Yeah, I don't think people will write programs anymore, right?
Yeah.
Programs will be generated and prove themselves correct. Yeah. But we still have to be able to state what we want. And actually, that's not as obvious as it looks, because we don't know exactly what we want. Actually, many people don't even know logically what they want. They say, hey, I'm interested in mathematics and physics. And then if you search for mathematics and physics, the intersection is very small. Actually, what you mean is that you're interested in mathematics or physics.
Yeah.
So when you start writing down formally exactly what you want, you'll realize that it's not that clear, actually, what you want.
Yeah, I mean, a lot of us don't know what we want. My wife asked me what I want for dinner. She'll never get an answer. The AI agent that that I thought was most interesting is this agent called eSelf AI. It was built by this company. I think it's an Israeli company, and the agent generated over $100 million in closed leads for a real estate company in Portugal. I was thinking that was one of the real, like, tangible use cases of an agent that is actually, like, real. I thought that was pretty cool. Anyway, so we're out of time. Thanks, everybody. That was good.